Hey guys, I just wanted to walk you through the notes that we took over quadratic solutions because you end up with kind of some interesting connections between different versions of quadratics. And so, first thing I want you to notice always is that quadratic equations, ones that have an x squared in them, always have to equal 0. Or they might equal y or f of x, okay? Basically, the entire equation will be on one side of the equal sign, all the information together, so that when you are solving or graphing, you have everything on one side. So we end up with three kind of synonyms that all mean the same exact values, okay? You will see star questions that ask about what are the solutions to this quadratic or what are the roots to this quadratic. Sometimes they will reference what are the zeros of this quadratic, and then also you end up with what are the x-intercepts of the quadratic. And we worked through a paper in class that kind of walked through your three different versions of a quadratic and your different methods. And what we found in class was that no matter what you looked at as far as these three different scenarios, these same special answers or solutions tend to pop up over and over again. So when a question asks about the solutions are generally talking about what's happening in the equation, okay? You're super focused on an equation. So for example, I wrote a little quadratic equation here, x squared plus 2x minus 3. You have several different ways to solve equations on paper. If it's a quadratic, you can factor it. You can use the quadratic formula. Or if the setup is right, you can just take square roots to use inverse operations. That's why they're sometimes called roots, because you can sometimes take just the square root as an opposite. This one, we can't take the square root because we have x squared and an x. So remember from all of the notes over solving quadratics, that doesn't always work. So this particular problem will factor. It's a simple trinomial, but just to mix it up because we haven't seen it in a while, I went ahead and solved it with the quadratic formula. So that negative b plus or minus b squared minus 4 times a, which is 1, times negative 3, which is c, all over 2 times a. So I used the quadratic formula. If you need to have a little review on quadratic formula, go look at those notes. But I could have factored this. Some people in class did factor it. And we all figured out that the answer ended up being positive 1 or negative 3. Remember, with the quadratic formula, you're going to solve this once on the calculator with a plus and once on the calculator with a minus. And I end up with these two answers if I solve it the way that we have been solving all year long. The second version of the solution that you might see is called a zero. This is when you're looking at a table. So we end up with, I'm going to focus just on that side. So it's when your x values pair up with a y value of 0. So what I did is I took this same exact quadratic from the first example, that x squared plus 2x minus 3, and instead of equaling 0, I just had it equal y. And basically what I ended up doing was I put it in the calculator into a graph page. So there's my equation right there, the x squared plus 2x minus 3. And then remember, to get the table from this, I'm going to do Control T. Control T will give me the table. That's a little squashed. So I personally like to do Control 6 to split it apart. And then you see your second page right there has your table on it. So Control over will get me there. And when I start looking at these table values, I notice that there are a couple of places that equal a 0. So at negative 3, it pairs up with a 0, and at 1, it pairs up with a 0. So all I did was in the notes, I copied down that table value exactly, okay? I just picked some values so that I could see, hey, those are the two numbers that make a 0 for the y. This one is confusing. People sometimes think it's a 0 because it has a 0 there, but it's not. The 0 has to be in the y value. You're looking for what x's make a 0, not what 0 makes, if that makes sense. And notice, same equation, same quadratic, those same two numbers pop out. So I could solve and end up with 1 and -3. I could look at the table and the zeros tell me that 1 and -3 are significant numbers, okay? The third way to find the answers to your quadratic are, we kind of discovered that your x-intercepts, where the graph touches the x-axis, also shows those same values. So what I did is I took the graph, and we saw it just a minute ago, but let me get back to it. And if I zoom in on that graph, you'll notice that at the -3 and at the +1, that's where this graph is crossing the x-axis. So you basically have 3 different methods that all reveal the same key numbers about this quadratic. You can solve it from an equation. You get -3 and 1. You can look at the table and see, where does that table give you a 0? And it's -3 and 1. And then you can look at, well, where does that graph touch the x-axis? This is just a sketch of that same graph. I used some specific values. And the table, or the graph, is also showing me -3 and 1. So the reason we learn all these is because when it comes to testing, now that I know that all 3 of these show me those same values, I really, if I'm not real good at solving quadratics, here's kind of a shortcut to find those solutions. If tables are confusing, I can just look at the graph and find the solutions. A lot of people really liked the table the best. They felt like that was the easiest one. It is if the numbers are clean. If the numbers aren't clean, the table can get kind of funky. You have to kind of change what your table settings are so that you can see maybe your answer is 3.5 or 1/3. You start getting kind of tricky getting the table to show you those on the calculator. So to me, the graph is the easiest way. I just look, where does it cross the x-axis? Those are my solutions. It gives me the same exact information that I could get from solving it by hand. So if you get a quadratic, you can actually use any of these methods to get those solutions. And like I said, sometimes the question will call them solutions. Sometimes the question will ask, what are the zeros? You need to know it's the same. Sometimes it's asking, what are the x-intercepts? That's the same as the solutions. So all 3 of these are kind of like alias names. They're all also known as zeros, also known as x-intercepts. So just know that if you see a question, it may be worded different ways, but they're all asking for the same stuff.